All right, hey folks, welcome back to our course in trigonometry. In this video we are going to discuss applications. Now, what we're going to be doing is we're going to be modeling a realistic situation and then using the principles that we discussed in our previous videos pertaining to solving right triangles, we're going to use those ideas to answer questions about the situation. So let's get right into it and work an example. A road goes 2.5 miles uphill, making an angle of 5.1 degrees with the horizontal. And the question we'll try to answer is, how high is the hill? Okay, so we've got a road going uphill. The hill makes an angle of 5.1 degrees with the horizontal. The question we want to know is, how high is the hill? So let's get a little picture going right here. So that angle is 5.1 degrees. This is 2.5 miles. And we're trying to answer this situation. Okay, so we're pretending that we've kind of taken a slice of the hill and we're looking at the cross section of that slice, modeling the hill with a triangle, basically. Okay, modeling with a right triangle. And we're going to use the principles that we discussed in our last video to figure out this height h. So the question is, what do we have and what do we want to know? Okay, well, we have this angle and we have the hypotenuse. We want to know that side length. Now, from the perspective of this angle, that's the opposite side. So we got the opposite, we got the hypotenuse. There's a trig ratio that involves opposite hypotenuse. It's the sine function. Okay, so sine 5.1 degrees equals opposite over hypotenuse, h over 2.5. So if this equation is true, we can solve it for h, multiply both sides by 2.5, and we get h equals 2.5 times sine of 5.1 degrees. Let me grab my calculator, it's right over here. So 2.5 times 5.1 sine equals, okay, I'm getting 0.22. Let me just run the calculation again. 5.1, take the sine, times 2.5 equals, okay, 0.22. I am rounding that to two significant figures there. A little multiplication there. So the height of the hill, 2.5 miles, using the principles that we discussed in those previous videos. So the theme for working with these applications is look for a way to work in a triangle. Try to draw a picture of the situation using a triangle. And then use your principles of trigonometry to get the information that you need. Let's do another example here. The angle of elevation to a tower is 57 degrees 24 minutes. We are 50 meters away from the tower. And the question we'll answer here is how tall is the tower? Okay, so just so we're all on the same page here, here's your horizontal. If you're looking up at something, we call that the angle of elevation. Okay, so if I'm looking up at the corner of that room, the angle that makes with the horizontal is the angle of elevation. If I'm looking down at the floor, well, that's the angle of depression. Okay, so angle of elevation, you're looking up. Angle of depression, you're looking down. So here's our picture. And let's pretend it's like a, I don't know, a radio tower or a cell phone tower or what have you. So we got a situation looking like this. So we're looking up at the tower. We're over here, 50 meters away from the tower. They tell us this angle is 57 degrees 24 minutes. And we want to know the height of the tower. Okay, so I got my triangle here. The 50 meters is along the horizontal. That's the base of my triangle. I want to know the height. I know this angle. Okay, so I know from the perspective of this angle, I know the adjacent side. I want the opposite side. We got to think of a trig function that involves opposite and adjacent. It's not too many of them, so sine is opposite over hypotenuse, so that won't work. We don't know the hypotenuse. Cosine is adjacent over hypotenuse. Once again, that's out. Tangent is the one we need. That's opposite over adjacent. Now, one thing to do here before we go and use our calculators with this angle, I'm going to convert it to decimal degrees. You remember how to do that from the video where we talked about calculators and trigonometry. You take your minutes, divide by 60, because there's 60 minutes in 1 degree. Okay, do the computation on your calculator, take 24, divide by 60, it comes up to 0.4. 57.4 degrees. Okay, so that's what I'm going to use in my calculator. And the equation I'm going to set up is tangent of 57.4 degrees equals opposite, the unknown side h, over the hypotenuse, which is 50 meters. And if this equation is true, then that means I can solve it for h, multiply both sides by 50. So I take 50 times the tangent of 57.4. So I just knock out that computation. So 57.4, take the tangent of that, multiply by 50. So I'm getting 78.1. Oh gosh, this measurement only has one significant figure, so I probably should do just one significant figure in my answer. So 78.18, well, 78.2, but if I go one significant figure, I'm guessing we should do 80. Okay, so this is approximately 78.2, but if I'm following our significant figure convention, I would do just one. That doesn't have a decimal, so just one significant figure. So we'd round that to there. Okay.